Hello my friends, and welcome back. In today's video, we're going to be taking a look at a brand new project. That project is Masir. Masir is a focus follows mouse daemon for Windows 11 and above, written of course in the Rust programming language. The word masir is found in a lot of Central Asian languages, and it means vector, the means by which you reach a destination. I thought it was a fitting name for a focus follows mouse daemon after it was suggested by my wife, who, if you didn't already know, was the person who chose the name for komorebi. So this is Masir. This is the repository. It is already up on YouTube. You can install Masir now. In this video, however, I wanted to do a quick little code walkthrough. I thought it would be quite nice because there are only a handful of commits, and I thought it would make an interesting case study of how to start with something basic and then introduce what's the word that I'm looking for? To introduce approaches, let's say, to optimization. So I am also going to be doing another first in this video, and that is using the Z code editor to go through the code. I had mentioned in a previous video that I was playing with the Z code editor. They've recently merged some changes that have made not performance, but the implementation on Windows a little bit better. Previously, it would spawn a whole lot of terminal windows when it was loading LSPs and stuff like that. That has been significantly reduced, so if you want to try building that from source now, I think it's a good time. So why don't we start from the initial commit? I am going to git checkout 993BCET, and that will bring us to the very first version of this main RS file. What is this? Oh, is this the diff from master? That's pretty cool. Alright, so we'll start from main. So let's have a look. What are we doing here? We are parsing some options. So the only option that we have for Masir is HWNDs, which is a path to a file with known focusable HWNDs or window handles, such as the komorebi HWND JSON file. Fun fact, you may not know, back in the early days when you could still lose windows with komorebi, I started writing out all of the window handle identifiers to a file so that if komorebi did crash and you did lose all of your windows, or you didn't lose them, but they were hidden, and it was very difficult to get them back. So I implemented this restore windows command, which would look for this JSON file with all of the window handles, and then restore them in the event of a crash. This file is still there. It's still being written to, and I thought, you know what, we're going to use this here. I'll go into that a little bit later. So this is an option to a path buff, which is a pointer direction to a file. So we match against this, and if it is not provided, we try and look for the komorebi HWND JSON file. If it's a file, then we'll use that path buff. If not, we say, we don't have one. And if we explicitly give like a masir HWND's location here, then again we want to check, is this a real file? If it is, we will use it. If not, we'll just discard it. We do some setup that you may have seen if you've looked at komorebi, if you've looked at WHKD. Very similar. We set some Rust variables. So I always want to make sure that I have a library backtrace. I want to install color which is an error report handler for panics with colorful, consistent, and well-formatted error reports for all kind of errors. Just makes debugging a bit more easy on the eyes. And then if we don't have a Rust log value, we just default to info. But this allows us to set that to debug or to trace for additional information if we want. Then we initiate the logger, and then we start listening for movements. And this is where the meat of masir lies. So we have some Control-C handling, whatever, but this is what we're going to look into, which is right here. So we spawn a thread, and we start message loop. And message loop is a third-party crate, which, well, it doesn't really show you here, but it lets you listen to events. And there are a whole bunch of different kind of events, right? Keyboard events, mouse move events, mouse button events, and mouse wheel events. For our use case with a focus follows mouse daemon, what we're really interested in is the mouse movement. We don't particularly care about where it's moved to. We only really care about getting that notification that it has moved. So what do? We get the window at the current cursor position, and we also get the foreground window. And these are just calls to Win32 system API calls. Calls to API calls? Calls to system APIs, that's what I mean to say. So we have, window from point, we have get foreground window. All of this stuff basically I just copied and pasted from the komorebi Windows API file. It's already there. I'm just going to reuse it. So we are getting the window handle for the window at the cursor position and the foreground window. Then, if the window handles are different, we start doing some logic. So I have this state tracker, should raise. And step one, we're going to test against some known classes. So we have a block list, which we go here. That block list is for the desktop window, the tray, the start bar, icons, and the start menu. And we have an allow list, which I don't want to get into this. I have so many thoughts and feelings about Electron applications, mostly that they are gross. But when you get the window handle from the cursor position and you look up the class, it's always going to give you this. Not cool at all. But it's okay, we deal with it. So step one, test against known classes. So we get the real window class of the window handle at the cursor position. If that succeeds, we check to see, is it in the block list? If it is, we just continue our loop. We're just discarding this event. Then, if this class is in the allow list, which right now at this point in time is just the Chrome render widget host HWND class, then we update our state. We say should raise is going to be true because it's part of the allow list. Otherwise, if at this point we don't know whether we should raise or not, whether this is still set to false, then we'll just trace this out, right? And this is just really to help me with debugging. So step 2, if available, test against known HWNDs. So this goes back to the file, right? The komorebi.hwnd.json file. So if at this point we still don't know if we should raise, and we have a file which is populated with these window handles, which are like integers, basically, they're positive integers. We will read to string the contents of that file. And if the contents of that file contain that integer, we cast it to a string here, we say, okay, this window handle was found in this file that has been given to us. And in the case of komorebi, this is a file of managed windows, right? The window handles to managed windows. And if it's a managed window, we know that it is like, it's good to focus, right? It's not like focusing the tray where it's going to get all weird. It's not like focusing the start menu icons. Like, it's a regular window. It's one that we want managed, so it's also one that we want to focus when our mouse moves on top of it. So we set should raise to true. Then if we should raise, then we raise and focus the window. And that's the core loop. Now, if you want to pause the video for a second and think about what we have here, just think if you can identify some areas for optimization, right? Like, what are the expensive things that we're doing here unnecessarily? So I'm gonna imagine at this point that you have paused and thought about it and you've unpaused, and now we're back. So I'm gonna go back to master. I'm gonna do git commit one. Oh, is that? No, not git commit. Git log one line. There we go. There was another commit where I introduced some custom handling for Windows Explorer. There's going to be a lot of custom handling. I'm not going to go so much into this commit, but this subsequent commit. So let's check out that commit, and let's go back through our listen for movements function. So now what do we have? Ooh, we have a hash map. We have an illegibility cache. We have a map instantiation time, and we have a max age, which is 10 minutes. So at the beginning of our loop now, before we were just receiving the event, but now at the beginning of our loop iteration, we check if the time elapsed since the initial creation of the illegibility cache has exceeded 10 minutes. If it has, we clear that cache by just creating a new hash map. And when we create that new hash map, the old one is going to get dropped. And then of course, we update the map instantiation time. So in effect, this means that every 10 minutes, we are going to completely empty that cache. And that's important, right? Because let's imagine that this daemon is running on your machine for days, for weeks, maybe even over a month. That hash map is going to keep growing with every single window handle. And that's just not something that we want. So I figure, 10 minutes is good enough. 10 minutes is good enough. Maybe we can come back to that. Maybe we can make it a bit longer. Maybe we can make it configurable at some point. But for now, the main concern is we have this cache, and we want a mechanism by which to empty that cache so that memory for this process doesn't keep ballooning and growing. So we're back now at the event handler. So we get a mouse move event, and we get the window handles again for the window at the cursor position and the foreground window. But now we have another state variable. So we had should raise, and now we have should cache. So we check this block here. The comment says check our cache first. So we look in the illegibility cache, and we see if we have an entry for the window handle of the window at the cursor position. And this is a hash map of iSize, window handle, to Boolean. So if the Boolean that we get from our cache is true, if illegible, then we set should raise to true. We also emit a debug log. Otherwise, if we don't have a hit in our cache, we set should cache to true. And we're going to come back to this one right at the end of our loop iteration. So once again, if at this point we don't know whether or not we should raise, we do our tests against known classes. We have some Windows Explorer related handling for early exiting, continuing the iteration if these conditions are met for Windows Explorer related weirdness. Then we check against our block list, we check against our allow list, and we emit a trace log if at this point we don't know whether or not we should raise and focus this window. Step 2, if available, once again, we test against known HWNDs. So at this point, right, notice that if should raise is true, we have already skipped 2 system calls to look up classes. Then, because this is part of that same block here, right? It's part of that same block. We can also potentially avoid this read operation, because remember, we are reading this file of window handles on every loop iteration, or we were in the initial implementation. Now, if we get a hit in the cache, we also get to avoid this potentially expensive call to open and read from this file. Pretty cool. And then, if we have decided that we should raise, that we should focus this window that the mouse cursor is now on, we can check this new state variable, should cache, right? So if we go back up here, if it wasn't in the cache, and we went through all of these steps and we have determined that, okay, this one is okay to focus, then we want to make sure we cache it for next time, right? So we insert that into the eligibility cache, and then we go ahead and we raise and we focus. So already, we have eliminated 3-4 system calls. I'm not sure how many system calls this is, since it's abstracted with the Rust standard library. But we're not needlessly making this system call to retrieve the class of these 2 window handles. So let's get back to master, git log one line. And actually here, we are at the latest commit now. So let's take a look once again at listen for movements. So now we have an eligibility cache, a class cache, and a window handle pair cache. I'll talk about this a little bit in just a moment. So we still have our instantiation time and our max cache age. Now, in this if block here, we are going to be clearing all of our caches every 10 minutes. We have more than one cache, so we have to clear more than one cache. Then we get into the event handler for mouse movements. So if we have a window handle for the window at the cursor position, if we have a window handle for the foreground window, and if those 2 are not the same, we are going to do a lookup in the window handle pair cache. So let's take a look at the log here. There we go. So window handles, cursor position window handle, and foreground window handle are known to refer to the same application. skipping. So we get to skip all of the computation here if we already know that we have two window handles that refer to the same application. And this is actually what is happening here. Windows Explorer fixes, also fixes for Steam. This one relates to Electron weirdness. But basically what happens is there are multiple window handles stacked one on top of each other, you know, the way that these applications are put together. And depending on where you focus it, or where your cursor is on the application, when you get the class for the window handle where the cursor is, it may be the same as the foreground class. So I could have my mouse on top of this window now, and the cursor position class, so the cursor position is on top of Z, that could be one thing, whereas the foreground window class, still the same application, Z, it could give a different class. So this is what we're doing here. We're just making sure that if we already know that this is a pair, right, a pair of window handles, we can just skip. We don't need to do anything because the window that we're on is already the focused window. It just has a different window handle, but we know it's the same application. Then let's take a look at our state here. So we have should raise and should cache eligibility. So some renames, but basically the same thing that we had in the last commit. And now we are doing something new. We are checking our class cache to avoid system calls. So we will attempt to get the class from the cache. This returns an option string. And the reason why I have this as an option string here is because if we do not have that in the cache, we still want to make that system call, right? But the difference here is if we have to make that system call, we are going to make sure that we cache the result being the name of the class. And we do that for the cursor position window handle and the foreground window handle. And then we do the same thing. If we were able to retrieve these classes, we check our fixes for Windows Explorer, for Steam, probably other apps in the future. We probably want to make this configurable at some point, but you know, so far so good. And then after that, we check our eligibility cache, because what is happening here, right? Even all the way up to here, we are prioritizing exiting early out of the loop, out of this iteration of the loop, right? So we have continue, we have here continue, and here before we continue, we're inserting our window handle pairs into the window handle pair cache, so that we can hit this continue even earlier, all the way up here, without making potentially unnecessary calls to real window class. So we get to here, and then we check the eligibility cache. And this is the same as what we were doing in the last commit. We update our state if we don't already have it cached to say that, hey, if we get to the end of this processing and it's okay to raise, I want to skip this next time, so let's make a note in the eligibility cache that this is okay to just raise. Then we check our block lists. If we don't already know the eligibility at this point, we check the allow lists. And then we are also, if at this point we don't know based on these known classes, we're also going to check against our file of window handles. So I've lost track of how many system calls we are going to be saving with some smart caching. Yeah. So at the end of it, you know, if this is eligible. We are going to update the cache eligibility if necessary, so that we don't have to go through all of that processing next time. And then we raise and focus the window. So you haven't seen this in action yet, have you? So I am going to do a little demo. I have to run it in here because Z still doesn't always play well with the terminal. So I'm gonna run masir. Masir is now running and additionally checking window handles against the komorebi hwnd.json file. So I'm gonna move over here and we're gonna see we raise this window handle. We're gonna move back, we raise this window handle. I'm gonna move here, then we raise the Z window handle. And you can see by the way that this is changing borders, that the focus is also changing. And you can also see in the status bar that the currently focused window is also being updated. So this is cool, I guess, but wouldn't it be cooler to see it with the different log levels? I think it would be cooler. So we're gonna do just debug, which is running cargo run with the Rust log variable set to debug. So here we are. So I'm just gonna do this a little bit and then we'll take a look at the output here. So this window handle was found in the file, so we raised it. Then we find the class for this window handle in the cache. And we also find the class for Z in the cache. And we also find this here, so we raise it. And then next time we go to Z, we can see that it was found as eligible in the cache, right? So we skipped this call here to read in the HWND file and match against that. Really cool, really cool. Of course, trace gets even more verbose. So we're running this in trace now. Actually, not that much more verbose. It just makes sure that you have a window class every time, even if something at a certain point is not found in a cache or is not known to be an eligible window. So that is it. I think that is everything I wanted to run through. Perhaps I should say one more thing about this, and that is the whole reason that I ended up making this as a standalone thing is because focus follows mouse in komorebi is now actually end of life, which means that it is not going to be updated anymore because it was a real pain in the butt. It was such a pain in the butt. It's going to be a lot nicer to handle outside of komorebi, if I'm honest. So if no, it's not there. It's in the config. There we are. We have a couple of end-of-life features, but here we are. End-of-life feature determines focus follows mouse implementation. Such a tricky phrase to say. Focus follows mouse. So anyway, that's end-of-life. The komorebi implementation still works. It's just not going to be receiving updates or bug fixes or anything like that. So if you are somebody who has been using komorebi focus follows mouse, your new stop is masir. That is what is going to be receiving all of the love. The other thing that I want to mention about masir is that it doesn't have a dependency on any specific external software or tiling window manager. You can use this without komorebi, right? The only thing that you gain from using this with komorebi is that you have that additional list of window handles to do an extra check against. What this also means is that integrations with other tiling window managers are both welcome and hopefully very easy. So if you would like to create an integration between Masir and another tiling window manager, there's only one requirement, which is an updated list of window handles known to and managed by the tiling window manager, written to a file somewhere, like in a known location that you can pass to the HWND's flag. And once you've tested it out, once you've made sure that it works, you can just come, there is a to-do here. Where is it? Here we are. We can add checks for other tiling window managers here. So just like we're doing this check for the komorebi HWND's file, we check is it a file and use it automatically if it is. We can do that for any other tiling window manager. So if you use a different tiling window manager, if you are working on another tiling window manager, consider adding support and integration. They'd be very, very happy to expand the automatic integrations even further than komorebi. Oh my gosh, we're at 30 minutes. How did we... This was intended as a very short 10-minute video. I don't know why the time goes. I just get so caught up. Well, I hope that you all had fun and that you learned a thing or two about building something that just kind of works first and then iterating on optimization. And hopefully you can put this to use in your own work, in your own projects. And if you do, please let me know how that turns out. I always love hearing from all of you in the comments about what you've learned, how you have applied it. So I will be looking forward to those comments, hopefully in this video or in the Discord. The Discord, by the way, the Discord will be in the description. All of the links are always in the description of the video. If you like this video, please do make sure to like and subscribe in addition to leaving a comment. The GZ Codes channel is now a fully monetized YouTube channel, which is super cool for a number of reasons. But the biggest reason is that all of your watch time, all of your interactions, all of that stuff, it adds up in the form of ad revenue. And it's crazy, but it's true. It is a really simple, easy, and most importantly, a passive way for you to financially support projects like Masir, projects like komorebi, projects like WHKD. So please do make sure that you are subscribed, that you hit like, and that you leave a comment. My friends, I hope that whatever you all do today, you have a great day. Free Palestine, and I'll see you all back here next time.